What are semaphores and where they are used? Let's see. If you want to work with the multi-threaded system, you'd likely come across these. Semaphores are synchronization primitives used in programming to control access to a resource. That resource can be a database connection or even a variable. But when you're working with multi-threaded environment, that means different threads want to access some data at the same time, probably, and you want to prevent some race conditions in that scenario because there could be some scenario where you don't want a value, but some other thread wrote that value to something else. So you want to prevent that basically. So let's see how semaphores prevent this from um, happening with this example. The example I'm going to demonstrate here is as follows. So think of a scenario where you have two printers at your office and six of your colleagues want to print on that printer at the same time. And you want to prevent this because since there are two printers, max two of your employees or the employees should be able to print on that printer. So if we spawn a thread for each of that employee, what we basically want here is to see. So I have timed this script, so whatever time it takes, there is a sleep time for whatever time it takes to print one printer. That's to mimic the printing time. But what we are expecting here is a total of overall 3 seconds, because there are six employees and two printers, so 6 divided by 2. We want to see around 3 seconds. So this script should take around 3 seconds if everything goes well. So let's run this script. Right. Okay, so this is definitely strange because everything ran in 1 second. So there is a race condition. So that is a race condition that I was talking about. So let's solve them. Um, let's solve all of these problems with semaphore. Let's see how semaphores can help us here. So let's bring in the semaphore, which is like this. And right before they start printing, they have to get the permission. So they have to basically acquire a printer, then start printing. So, and if there is no printer available, they have to wait for the one of those two printers to be available. And then when they are done, they have to release the semaphore. The printer is basically available for the next person. Until then, the next person has to wait for, like in a queue, to print. So let's see how this acquiring and releasing mechanism affect our results. So we had 1 second, and now we have semaphores in place. Let's see how long it takes now. So again, what we want to say is right around 3 seconds. This time we do see around 3 seconds. So here you can see Alice first came to print, start printing, and then Bob came, was like second in the list. Alice done printing. As soon as Alice done printing, that means there is one printer now available. So Charlie took that printer. So here we can see that's represented. Then Bob done printing. And then we can see David, who is right after Charlie in the queue, took the printer, and then so on. And we did see the right result. So that's how semaphore prevent the race conditions in the multi-threaded environment. This function is basically running in a separate thread, but it still need access to, it still needs permission to access a resource. So that is the power of semaphore. It's simple, but a really powerful concept.